In the Riemann Sums 1 video and the Riemann Sums 2 video in the bonus sections, we talked a little bit about this notation right here. This represents a Riemann sum with n subintervals. Here I've drawn an example. Here's a function f of x. We've split this interval from a to b into 9 subintervals. We add up the areas of all of these rectangles, and we get an approximation to the area underneath this curve. Well, if I call this sum s sub n, where n is the number of subintervals that we split this problem into, and I take a limit as n goes to infinity, what I explained in the Riemann Sums 2 video is that this sum adds up to the exact area under this function between the x values a and b. Well, there's some notation that you can use to say the area under f of x between x equals a and x equals b, and I'm going to show you that right now. Remember this integral notation from our antiderivatives videos? Well, what this notation says is that the integral with respect to x from x equals a to b of the function f of x is the area under this function between a and b. Now we're going to have plenty of time to mess with this notation later. For now, we're just going to say that this is the way that we write the area under curve between two x values. Okay, I'm going to move all this to the side and give myself a little bit of room here because we want to try this problem right here. And you'll notice that this summation notation is the same as this notation right here. Namely, you'll notice that there's this function f of x which appears right here. You can see just by looking at it that this f of x we're talking about is 6x to the fourth minus 4x to the fifth power. So if we drew a picture of this function, we could break that function then into n subintervals, and it would look something like this. And this sum represents the approximation of the area under that curve on the interval, which they've given us is just -2 to 2. Now if we take a limit of this sum as n goes to infinity, that will represent the exact area under this function on the interval -2 to 2. And how do we denote the exact area under this function on the interval -2 to 2? Well, it's this new notation that I just gave you. It's the integral from -2 to 2 of 6x to the fourth minus 4x to the fifth with respect to x. So this limit represents that exact area, and that exact area is denoted with this integral here, and that's the answer.